Hello, this is Adam Paulson, welcoming you to this Bite-Sized Bio webinar, which today is sponsored by Eppendorf. Eppendorf is a biotech company that develops, produces, and distributes systems for use in all spheres of life science. The company's broad range of high-quality products and systems is used by researchers worldwide to carry out their work efficiently. Today's presentation is titled Reproducibility, Mastering the Art of Pipetting, and is being presented by Dr. Barbara Siefke, Product Marketing Manager, and Dr. Ulrike Gust, Application Specialist, Manual Liquid Handling and Pipette Calibration Service, both of whom are from Eppendorf. Barbara obtained her PhD in developmental biology in 2004 from the University of Cologne, where she researched the asexual reproduction of jellyfish using molecular biology techniques. She went on to gain sales experience at PerkinElmer and Microsynth Seek Lab before joining Eppendorf as Product Market Manager and Manual Liquid Handling Certified Trainer in 2014. Barbara has been Product Marketing Manager for Manual Liquid Handling Solutions in Europe since 2018 and is happily celebrating the 60th anniversary of Eppendorf piston-stroke pipettes this year. Ulrike specializes in applications of liquid handling systems and in teaching their correct use. She provides guidance to users to solve difficult pipetting questions and has supported Eppendorf Pipette Calibration Labs in their accreditation process. Ulrike holds a PhD in biology from the University of Tübingen. She has a great deal of practical experience in both the correct use and liquid handling systems and their performance testings. As always, we will have a question and answer session after the presentation. So please type any questions that you have into the questions box, which appears at the bottom of your screen, and I'll put them to Barbara and Ulrike at the end. A link to view the recording of this webinar will be sent to you in due course. So now over to you, Barbara and Ulrike, for the presentation.
Thanks so much, Adam, and welcome everybody. Reproducibility, mastering the art of pipetting. That's our topic today. And we will guide you today through difficult liquids. We will talk about functional principles and pipetting techniques. But first, do we have the right information around us? We checked lots of pages on the web, and nearly 60% of the found videos around correct pipetting were not fully correct. This webinar should show you the right handling of liquids, and we want to eliminate some myths. And we'll show you where you can find the right information. As mentioned, we start with the liquid classes, or with difficult liquids. The most liquids in the life science research are unproblematic aqueous solutions. However, often we have also difficult liquids in the lab. This could be volatile liquids, viscous liquids, forming liquids, or some more, but we will focus on these three ones today. But how to handle them all? What should we do with all these difficult or different liquids? Let's have a short view into this video. Are you aware of this problem? This is a slightly colored liquid. I will tell you later what it is, or I hope you know what it is, and I hope you can see the dripping out of the tip properly. I have the first poll question for you. What kind of liquid do you think this could be? Please choose only one answer. Could that be water? Could that be oil? Could that be ethanol? Or maybe a detergent? And I hope you all see now the pop-up window and you can vote. What do you think could that be? Thanks for the results. So lots of you are voting for ethanol, and this is correct. Also, some of you go for water or detergent. Let's have a closer look into that. Volatile liquids are ethanol, as shown in the video, and most of you gave the correct answer. It could be also acetone or chloroform. And what is the problem here? We have a high vapor pressure of the liquid, and additionally, we have a lower surface tension than water. And the consequences here are that you, as shown in the video, that you have liquid drips out of the pipette tip. And this leads to inaccuracy and also to a non-reproducible result. And we have also contamination risk. You have the evaporation into the pipette cone. As shown here, the liquid evaporates into the air cushion of the pipette tip. A higher pressure builds up here, and the liquid drips out of the tip. What we recommend for this type of liquid, the best choice is a positive displacement system. Maybe you don't know this name, but you know the name maybe a stepper or a dispenser. We at Eppendorf call it multipette. If you have no air cushion, you have no problem. And later on, Ulrike will give you some more insights into that system. Another best choice is the visionized pipette manager system with the Explorer Plus. This system have liquids stored as a program inside this system, and you can choose between different liquids, like here, like ethanol. And when you choose that, there's running a program for you, so to say. In that case, for example, pre-wetting or pre-saturation, or working especially slowly, or. If you want to have more information about the Visionized Pipette Manager, please go on the link on our homepage, and you find that in the chat now. If you don't have a positive displacement system or the pipette manager, we have some tricks for you if you want to use the air cushion pipette. Very important here when using ethanol or other volatile liquids, pre-wet more than 3 times to decrease the frequency of dripping. You can very easily try that out with a non-pre-wetted tip with ethanol and a pre-wetted tip. And then you see the difference very easily. But we have to say this is not sufficient with very high vapor pressure chemicals like acetone or chloroform. The reverse pipetting technique can also be an idea to decrease the error, but this will not avoid the dripping. This will only reduce it a bit. And you should adjust the pipette temporarily to the liquid according to the user manual. This is our application note 198. What we found on the web, the recommendation of positive displacement is really rarely found on the internet. And this is a bit astonishing for us because it is the best choice. Here I have the next video for you. Are you maybe aware of this problem in the web? In the lab. As you can see here, there are bubbles inside the tip or inside the liquid. And another effect you will see while dispensing. Now here a huge residue is building up inside the tip. So we have remaining liquid inside the tip. This is a viscous liquid. And we would like to know from you, how do you solve this problem in the lab? So this time you can choose more than one answer. You can aspirate or dispense extreme slowly, or you can simply ignore the residue in the tip. Maybe you use the reverse pipetting technique. Maybe you cut the tip, or you use the positive displacement device. So I'm happy to, or I'm very curious about your answers. So let's have a look into that soon. Here we are. Okay, most of you are voting for aspirate and dispense extremely slowly. This is really, really good answer. And to ignore the residue is rare, and this is also very good. But also we see that some people are cutting the tip. And let's have a closer look into that. How users solve the problem with cutting the tip. Some people are doing that. And here we make an experiment to show the influence of cutting of tips on the pipetting error. And what you can see here is a systematic error and the distance of the cut off above the orifice. So orifice is the opening of the pipette tip. And shown here is pipetting water with a non-cutter tip and with a cutter tip of 2 centimeter distance. And the blue bar here, is the normal error limit for this volume of 1000 microliters. And you see with water and no cutter tip, it's a great result. With cutting the tip, even when you're only pipetting water, you are much higher than the error limits. And this effect is higher with glycerol. When you're not cutting the tip, you are inside the error limits. But when you cut the tip to use glycerol with 50%, then you are far away or far above the error limits. So you see, cutting the tip is not the best idea. Unfortunately, this tip is really often recommended on the web. So what are viscous liquids beside glycerol? It could be blood, it could be mineral oil, and mineral oil was a liquid we used in the video before. And the problem here is viscosity, the fluid resistance. You have a higher inner friction, and these liquids have a higher density than water. The consequences are you have an inaccuracy because of a poor flow behavior, because of the risk of air bubbles and drop formation. And you have leftovers inside the tip, as you can see here and as you saw in the video. And this leads to really poorly reproducible results. Here we show it in another way. Now we try to pipette 50 microliters of 85% glycerol. And this is a normal pipetting technique, a forward technique with an air cushion pipette. And as you can see here, the different pipetting steps are very, very diverse. These are not reproducible results. When you are doing the same with the reverse pipetting technique, the results are a bit better, I would say. They are not so diverse, but they are still not at the 50 microliters. But when you use a multipette or in general a positive displacement system, then the results are really, really reproducible, as you can see here. So as hopefully obvious shown in the diagram before, the best choice is again the positive displacement system. I know I'm repeating myself, but we have no air cushion, then we have no problem. And again, the Visionist Pipette Manager with the Explorer Plus could be a very good choice. Beside the predefined liquid types in the Pipette Manager, you can also define your own liquid types. Here is viscous liquids, and you can enter these values you will always find everywhere for your liquid, the dynamic viscosity, and then you define your own liquid type. If you want to pipette viscous liquids with an air cushion pipette, then, as most of you answered really right, work extremely slowly. And this is not so easy with a mechanical pipette. So the recommendation is here to use an electronic air cushion pipette. Also, the reverse pipetting decreases the error because we have a residue anyway in the tip. But I have to point out it decreases the error, but it not eliminates it. And again, here, it could be of good help if you adjust the pipette temporarily to the liquid according to the user manual. I have no other video for you. I'm sorry for that. But I have another poll question for you. Foaming liquids. How do you pipette foaming liquids? And you can choose again more answers than one. Use a positive displacement device, could be one choice. Aspirate, dispense extreme slowly. And or ignore the foam in the tip. What do you think? Yeah, I like these answers. Very good. So to ignore it is not the best idea. That's correct. Use a positive displacement device. It's a very good idea. And when you work with air cushion, aspirate and dispense extreme slowly. Very good. So with the foaming liquids, first, what are they? These are liquids who contains detergents. That could be in the lab, mostly protein solutions with high concentrations. For example, PCR master mixes or cell culture media. The problem here is you have an increase of bubble and foam formation, and you have additionally a change in the wetting behavior of the liquid. Sorry. And you have additionally a stickiness to the surface. And the consequences are the detergent sticks to the tip wall. Here in the picture, you see a blue colored detergent, and you see hopefully very good that that should be an empty pipette tip, but the liquid sticks to the inner wall of the tip. You have foam within the pipette, and the blowout used normally while pipetting leads to bubble or foam formation and splashes. So again, the best choice here is the positive displacement system. And again, I have to repeat myself, no air cushion, no problem. And also here, the Visualized Pipette Manager could help out. You have another predefined liquid type, the enzymes and antibodies. And here, again, as I mentioned before, a program runs behind, and in this case, working very slowly and without a blowout. If you would like still to work with an air cushion pipette, as most of you mentioned, work extremely slowly. And again, the recommendation is here, you are not able to work such slowly with a mechanical pipette. Please use an electronic pipette, and Ulrike will tell you a bit more about that in the next slides. Avoid performing a blowout when you have foaming liquids. You can apply the reverse pipetting technique, or with an electronic pipette, the dispensing mode. And you can use pipette tips with a low retention functionality. There are different companies, including Eppendorf, offers low retention tips. So these are our information about difficult liquids. And if you would like to know more, we have a liquid guide for you on our homepage. It's under the Eppendorf Handling Solutions. And there you find the liquid guide with lots of more information, with videos, diagrams, and so on. So please have a look there. And you find the link now, hopefully in the chat. And now I hand over to Ulrike.
Thank you so much, Barbara, for sharing some practical examples for challenging liquids. So by this, we have seen that there are some liquids that push the air cushion pipettes to their limits. And in such cases, we have seen that it is better to use a different liquid handling system. And Barbara already mentioned the positive displacement instrument. So this is also an example for the fact that there are varying requirements of the different applications in the lab. And that we need different tools to really answer that accurately. And for that reason, there exists a large bouquet of options. So think of the different instrument models and the different volume variants and the tips with the different features like filters or certain purity grades. Alone the Eppendorf catalog shows about 1,000 solutions. The interesting question now is when to use which. And in order to help you a little bit through this question, it makes sense to step back and differentiate a little bit by the main functional principles. And these are the air cushion versus the positive displacement, mechanic versus electronic, and handheld versus automated. Let us start with the air cushion versus positive displacement instruments. To understand when to use them, we need to take a look at the construction of these tools. The air cushion pipette basically consists of air. Okay, there are also a piston and some mechanics enabling you to move the piston. But in principle, it is a piston moving air. And when a tip is attached and immersed into water, the system moves the liquid too. It's a very simple system. Unfortunately, the air cushion is sensitive to influencing factors such as temperature, holding angle, or other liquids than water. And as a rule of thumb, the bigger the air cushion, the bigger becomes the pipetting error induced by these influencing factors. And this brings up a question. Wouldn't it be good to have no air cushion at all? Indeed, we have seen challenging liquids are transferred best with a so-called positive displacement instrument. Here, the piston is built into the tip, not into the instrument. And that has the great advantage that the liquid runs up to the piston and the air cushion is avoided, with a little exception of a small air bubble. Influencing factors on the air cushion do not come into play anymore. And since the piston wipes the tip clean, even sticky liquids like blood or glycerol can be transferred accurately. For these reasons, a positive displacement instrument is a perfect solution when pipetting challenging liquids. Let us now take a look at the electronic pipettes. Electronic pipettes are more ergonomic than the mechanical ones because you do not have to move the piston. The electronic pipette does this for you. So it supports you in terms of ergonomics when you have to process an increased throughput. Additionally, the range of the functions is bigger. They simply offer more modes. This is what you can see here on this little pop-up. So there is a number of the different modes of typically, programmed into electronic pipettes. And while with a mechanical pipette, you can only pipette, the electronic one also offers, for example, a dispensing option, which is especially helpful when filling plates. This mode enables an efficient working, as you will be faster when filling the plate by the dispensing mode. The third interesting aspect, although rarely mentioned in the internet, is the improved reproducibility of electronic pipettes. This graph shows the result of a study focusing the random error of pipetting at different volumes. As shown by the blue bars, pipetting with mechanic pipettes had a higher random error as pipetting with electronic pipettes, which is displayed by the green bars. The study was performed with skilled and well-trained lab personnel. The within-run precision and the between-run precision is better when the pipetting is done using an electronic pipette. And this means the electronic pipette helps to increase the reproducibility of your results. This phenomenon is caused by the motorization of the piston. Let us stay a little longer with this topic. You can lower the human error by applying good pipetting techniques. Barbara is going to show or to give you more input on this in a minute. We have seen that electronic pipettes further help in reducing this error. But there is an option beyond totally avoiding the human factor in pipetting, and this is the automation. Here you do not hold the pipette anymore, but the pipettings are done completely automated. The reproducibility is top. There are a number of advantages coming with an automation, but there is one more factor I would like to highlight. When you are pipetting, tasks often become very complex and you need to concentrate very heavily for longer durations. Automated systems can be of enormous help. An example is the normalization in the frame of NGS. Here, every cavity of a plate is to be filled with a different diluent volume, a task that can only be solved by a single channel pipette, as every well is to be filled with a different volume of water. Those of you who are doing normalization will agree that it is exhausting to repeatedly search the table for the needed volume, setting it on the pipette, and pipetting the water into the correct well. 96 times or even more. It is so much easier to just upload your Excel file with the dilution calculation and press the start button on your automation. So far about the 3 most important functional principles, but there's one more thing that needs to be mentioned, and I'm now having a question to you. What do you think, how much does a pipette tip impact the pipetting result? Is it 10% or 25%, or do you say or guess it's 50%? Just give it a guess. And maybe you are surprised. Okay, so the votings come in now. Thank you very much. So most of you say it's 25%. And as I said, you might be surprised. The ISO 8655, which is something like the Bible in liquid handling, shows that the pipetting error caused by the pipette tip can be up to 50%. And this is quite a bit. And here, I think it is important to understand that the pipette and the tip really build a system. And the tip, although being a single-used item, may have a great influence on the pipetting result. So it should be chosen with the same care as the pipette. This is due to the fact that pipettes are adjusted to a certain tip. Or let's be more precise, the pipette is adjusted to the shape of the tip. The tip's shape defines, for example, the air cushion size inside the tip. On this picture, you can see an Eppendorf 1000 microliter tip on the left. On the right-hand side, there are some competitors. Watch out for the difference in length between these tips. Manufacturer-wise, an Eppendorf 1000 microliter pipette will be adjusted to the Eppendorf tip on the left. When it is then used with one of the tips on the right, it will show an increased error and needs to be adjusted to the air cushion size of this alternative tip. This physical principle is true for all air cushion pipettes in general. Now, what can you do if you wish to use another manufacturer tip? You should look out for the tip-induced influencing factors, such as tip fit, shape of the tip, or quality of the tip orifice. So when you are introducing alternative tips, we recommend doing a performance test of this new system to check its accuracy. Send the pipette together with the alternative tips to a calibration lab. They will check and, if needed, adjust the pipette. All right, so this was an overview over of the main functional principles. Next slide, please. And now it's up to you to make the right decision for your application. So when being in doubt about the right tool, please feel free to apply our selection guide. You can find the PDF in the chat now. So it is time now to turn back to the air cushion pipettes. Again, the air cushion is sensitive to influencing factors, and thus it is important to have a good pipetting technique. Barbara is now sharing with you the most important aspects.
Thanks, Ulrike. Yeah, let's have a closer look into the pipetting techniques. As shown before, using the right tool is one part of the medal, but using it in the right way is something a bit different. And because we showed you before that the most problems caused by an air cushion, we will focus here on the air cushion pipettes. So this is where the problems arise. Here, a short overview about all the things you should have in mind when you aspirate and dispense liquids. To choose the right pipette volume is important. A small immersion depth, the holding angle, the pre-wetting or also the pre-saturation of the pipette tip, the slow and uniform piston movement, and the delay before taking the tip out of the liquid. These are all the things to have in mind when aspirating. And when you dispense a liquid, the holding angle is different than while aspirating. You should release a liquid against the wall of the vessel. And only if you have small volumes, you should release the liquid directly, the liquid in the tip directly into the liquid of the vessel. We will focus on these three ones, the right pipetting volume, the holding angle, and the slow and uniform piston movement. And if you would like to have more information on all the other topics, you will receive the source of that later on. First, I have again a poll question to you. You want to pipette 10 microliter. You have 3 pipettes available. With each of them, you can pipette 10 microliters. What would be your choice? You have a pipette of 0.5 to 10 microliters, a pipette of 2 to 20 microliters, or a pipette of 10 to 100 microliters. And I'm curious, what do you think? What could be the best choice? Let's have a look into the results. Okay, very good again. So the 10 microliters and the 20 microliters, or 20 microliters most voted pipette, but not the 100. And I'm happy to see that. So we have an experienced audience here. I will show you why you choose the right answer. Here is shown the systematic error while pipetting 10, 20 or 100 microliter with 10, 20 and 100 microliter pipettes and pipetting 10 microliters. The systematic error with the 10 microliter pipette is 1%. With the 20 microliter, it's only a bit higher. But when you see the result of the 100 microliters, we have a systematic error of 3%, and this is a lot. So our recommendation is choose a pipette always with the smallest possible air cushion. As we've shown before, the air cushion causes problems. So the smaller the air cushion is, the more reproducible is your result. Or we can say the closer the aspirated volume to the nominal volume is, the more accurate the dosing is. This factor is very rarely mentioned on the web, how important this is. And I'm wondering about that because you have normally all these pipettes in your lab, so it's easy for you to select the right one. But yeah, you don't find so much information on that. Let's talk about the holding angle, or let's first have a video to show that.
Our second topic is the pipetting angle. When aspirating liquids, you need to hold the pipette as vertically as possible. I will show you why this is beneficial with a series of 8 samples. Whoops. There we go. The more you tilt the pipette, the more variations you will get in a series of samples, since hydrostatic pressure in the tip changes with the angle. The more you tilt the pipette, the more liquid you'll dispense. It's difficult to control this effect, since the variations are too small to see with the naked eye. For best results, just keep the pipette as vertically as possible.
So here shown again, the while aspirating, you have to take care on the holding angle. Hold the pipette as vertical as possible during the aspiration, ideally at an angle of 0 degrees, sorry for that. And again, in the web, there's often mentioned it is okay to have a holding angle up to 20%. But why they recommend that? You will aspirate more volume, even if it is small amount more. And also, it will not possible for you to have always an angle of 20%. You have to estimate it. So we would really recommend to have always the angle of 0 degree. And here's also shown in a graph the vertical holding angle and an angle of over 45% when you hold it like that in the lab. And I would say we see it often in videos to have it like that. And these are results when you do it like that. We want to pipette 1,000 microliters. And here we have 1,006 microliters, around 1,006 or 1,005 microliters, while have a high or have the wrong holding angle. While vertical pipetting leads to a really accurate and reproducible pipetting. The third aspect of pipetting technique is working slowly. Today, we have the problem, we have to work fast and we are always in a hurry. And yeah, it's a high pressure, I would say, in the lab. And this is not the best choice while pipetting, because it's a very precise technique. And here we say slowly working is key. And as shown here in the picture, you have the sea and you have the fog over the sea. The same happens in your air cushion pipette. You have aerosols above your liquid. And the faster you are working or pulling the button vigorously, the liquid scatters into the pipette and you have lots of aerosols in the pipette. That leads to contamination on the one side, and it leads to inaccuracy on the other side. So to work really slowly, especially as shown before with some difficult liquids, please choose an electronic device. Here is shown our Explorer Plus or the Multipad E3X. And here you can see we have speed buttons, and you should select for difficult liquids. Not always, not when you work with water, but for problematic liquids, you can choose the slowest speed of 1 to pipette very, very slowly. And this leads to very reproducible results. Also, this is very rarely mentioned in the web, how important slowly working is and why, for sure.
Barbara, may I hook in here briefly?
Yeah. Yes, please.
There is one more aspect about the pipetting speed, and this is a factor that can be important when pipetting functional units like proteins or genomic DNA or cells, and this is the shearing. And in order to understand the shear force, we need to understand two physical contexts. Firstly, liquids move faster in narrow tubes than they do in tubes with a bigger diameter. And secondly, there is a velocity gradient from the wall to the middle. So towards the wall of a tube or of a pipette tip, the liquid speed is 0, and in the middle it is fastest. We know this phenomenon from, for example, from rivers, and where they flow very fast in the middle, and towards the shore they are rather slow. For your cells, the genomic DNA or the proteins, this velocity gradient between the wall and the middle is quite important. So the bigger the gradient, the higher is the shear force. And this means that, on the other hand, that you have two options to decrease the shear force. The first option is the tip's diameter, and the second option is the pipetting speed. And for pipetting liquids, which contain functional units like DNA, cells, or let's say genomic DNA, cells, proteins, etc., we recommend applying an electronic pipette, which is set to a low speed, or if not the lowest speed. Please note here that different manufacturers of electronic pipettes offer very different speeds. So I can, of course, only speak for the Eppendorf Explorer pipette here. You may now ask, what or why not using a mechanical pipette? And the answer is that all of us really tend to pipette too fast. And an electronic pipette ensures pipetting with a very low speed, with an even liquid movement and in a reproducible way. And these are factors that are beneficial for lowering the risk of shearing and making the experiment itself reproducible. Now, decreasing the pipetting speed paved the way for a safe transfer of most functional units. However, if you're working with very, very sensitive molecules or cells, even the lowest pipetting speed may be too high. And in this case, it can be meaningful to additionally apply a whiteboard tip. We have performed a number of experiments about shear force in liquid handling and its influence on the cell viability. And there's an application note coming in November showing the results and explaining this in more detail. So for those of you who are working with such functional units, please stay tuned.
And I saw, Ulrike, that we have just came out the Bio News, the Eppendorf Bio News with an outlook on that topic.
That's true.
But I have to ask you, should we talk about shortly also about maintenance of pipettes?
Yeah.
Because I would say it's an important topic too.
Oh, yes, it is. Yeah, you're completely right. So we have spoken about examples for challenging liquids now, about functional principles, and we have also talked about examples for good pipetting techniques. But as you said, this the performance of the liquid handling system itself is also quite important. And next slide, please.
Sorry. Now it works.
Yeah, so let's thank you very much. So let's have a look at this graph. It shows the performance of a pipette in standard use. And what you can see is that it alters slightly the performance over time. So when applying a trend line here, we can forecast that it will exceed the red marked error limits approximately in August 2022. So how can this be, and why do pipettes alter their performance? That's the next question I would like to explain to you. So it's because pipettes contain wear out parts, just as you know it from your car or from your bicycle. So you know that a new tire has a good grip and a worn out one offers only a poor grip. And in worst case, the worn out one may even burst. And due to the abrasion and the aging process, tires are wear out parts. And pipettes also contain wear out parts. For example, the piston seal that seals the air cushion. Another example is the O-rings on the cones of the same model, or of some models of pipettes. And factors like the frequency of the use or the aggressiveness of the transferred liquids influence also the lifetime of such wear-out parts. So in order to keep the pipettes at top performance and to avoid downtimes, they should become maintained and checked on a regular basis. The checks are called calibration, and the maintenance is as well as the calibration can be done by a pipette calibration lab. Okay, Barbara, this brings us towards the end of this webinar. We have shown you today that the reproducibility of a pipetting result is influenced by the liquid, the selection of the right tool, or let's say of the most suitable liquid handling system. It is influenced also by your pipetting technique and by the maintenance status of your pipette. Barbara, would you like to add something?
Yeah, I have only a bit. I have one or two last slides for you. So if you want to know even more, as Adam mentioned at the very beginning, we celebrate 60 years of pipetting, or of pipettes now at Eppendorf. So in 1961, we brought the first air cushion pipette into the market. And so we celebrate the 60 years with a very informative ebook. It's called The Science of Pipetting to Perfection. And you can download it on our homepage, but we would like to thank you to your participation into this webinar. And so you will receive this ebook as a PDF later on. So, and there are all this information mentioned today and much more information. So I hope you like it and you will find it useful. My last slide is only to summarize what we wanted to tell you. Ulrike summarized the main topics, but I would focus more on think about the source of your online information. So-called experts showing videos in the web are not always the right choice of information. The best idea to search for valuable information is or are knowledge databases, either from manufacturers of pipettes and tips, or also the calibration service companies. They are working the whole day on calibrating pipettes, and they are very good sources for good information. An example could be here an US-based company called Artel. This is a very trustful information base to have really good information on all that. So please don't trust always the information in the web. Go to reliable sources to find the correct information. That's it from my side, and thanks so much for your audience. Now you know the art of pipetting.
Well, thank you, Barbara and Ulrike. That was an excellent presentation, very interesting. We have a number of questions from the audience, and if anyone else has a question, please feel free to post it in the questions box, which appears at the bottom of the screen. So coming to the first question to either of you, Barbara or Ulrike, this question's from Andy, who wants to know, what do you recommend for pipetting a high concentrated sulfuric acid?
Okay, sulfuric acid. Yeah, so there are a number of options. So first of all, we have learned today that the best option always is the positive displacement principle. Again, I would like to highlight that the piston is built into the tip, and this has the advantage that I would say it is a more safe way to transfer an aggressive liquid like sulfuric acid. So of course, when we are talking about aggressive acids, we have also to talk about chemical compatibility. So are the materials of the liquid handling system resistant to these chemicals? And with the multi-pad and combi-tip system, which is our positive displacement system, I can say that is okay. And if you are, you could also, do it with a normal air cushion pipette. Although I would, as said, recommend the positive displacement system, but you could also do it with an air cushion pipette. And therefore, we offer our customers on the website a chemical resistance chart for our pipette, so you can check out if you have also other aggressive chemicals, organic solvents, or bases or acids, then you can check it if there's a chemical compatibility there. When we are talking about the air cushion pipettes and sulfuric acid, please take into account that the density of this liquid is much higher than that of water. And that means that due to the air cushion inside the air cushion pipette, you will have, or you are going to pipette a smaller volume than you set on your pipette. So again, this speaks for the positive displacement principle because there's no air cushion.
Thank you, Ulrike. So the next question, Barbara, this one is for you, and this is from Vinay, who asks, do we have to pre-wet pipettes every time?
Hey, Vinay, and thanks for your question. I will answer it. What is the answer? It depends. So the main question you have to ask yourself, how correct has to be your result. If you have to work in a very controlled area and you need very, very high precise results, then we would recommend for the most liquids to pre-wet, but you don't have to do it, for example, with aqueous solutions in general, because it's not such necessary. And on the other side, for foaming liquids, for example, this is not a good recommendation because you increase the error type. So for difficult liquids like ethanol, it is more than recommended. For aqueous solutions, I would say you don't need it if your SOP is not recommending it, so means your standard operation procedure of your protocol from your company, you don't have to do it always. But you should have it in mind that this is in some cases very, very helpful and leads to more reproducible results. Yes. I hope that answers the question. Mm-hmm.
Thank you very much. Ulrike, the next question is from you. This is from Anna, who begins by saying hello and thank you for an extremely informative webinar. And then she asks, I find pipetting small volumes of less than 10 microliters very problematic. After dispensing the liquid, I often find residues in the tip, but I'm not sure that the problem originates from the type of liquid, since my lab mates do not have the same problem when using the same reactors. Do you have any recommendations on how I can solve this problem? For me, it is very worrying because I'd like to improve my PCR performance.
Yeah, okay. Thank you, Anna, for this question. Small volumes can be quite troubling. I totally agree. And the smaller the volume becomes, the more, the greater the trouble is. I don't know what type of pipette you are using or which volume variant you are using. So always keep with a very small air cushion if possible. So pipette the 10 microliter with a 10 microliter pipette instead of using a 10 to 100 microliter pipette, for example. So that would be the first thing. The second, also check out for the tip quality. I don't know whether you have different pipette tips in your lab. Sometimes that happens. Just make sure that you have tips with a good quality, because I have feedbacks from the market where especially the pipetting of small liquid volumes can be troubling. Yeah, most important is probably really pipette slowly. And when you are doing the pipetting, just do not only, lift up the thumb, but then wait a minute and leave the tip inside the liquid. Wait a minute, well, not a minute, but wait a short time. Let's say count 20, 21, 22, 23, and then take it out of the liquid. And when you dispense the liquid, also be careful. Do it into a pipette it into a already placed liquid in that was previously placed in the tube, or pipette towards the wall. So do not do this free jet pipetting, because that helps the liquid to really run out of the tip. And of course, because you are mentioning PCR, I don't know whether you may use another, PCR master mix or things like that. So master mixes are different, and they can trouble because they contain detergents or tend to be slightly viscous. And also here, there may be difference between the reagents, really, and that can also be troubling. So, I mean, if we are talking about pipetting 10 microliter, I always recommend really to pipette into liquid that was already placed in the tube or in the plate. And then you can pipe it up and down to really make sure that everything runs out of the tip, in case you are working with, for example, a slightly viscous liquid. So that was a bunch of options now. And from my answer, you already maybe get an idea how difficult it sometimes is to solve customers' problems, because we do not know the background. So we don't know with which volume they are working, which pipette tips they are using, which liquids they're really actually pipetting. And so there's always a bunch of options or possibilities that can or may cause this trouble. But I hope maybe with one of my answers, I hit the core to help you. Otherwise, please, get back in contact with Eppendorf, and then we can try to solve your problem. Thank you.
Thank you, Ulrike. Barbara, a question for you. This one from Anna Meta, who asks, should a mechanical pipe test be stored vertically? And when stored, should they be on the biggest volume to preserve the spring inside?
To the first part, so the most important thing is never lay down a pipette with a pipette tip, and especially when a filled pipette tip. So then you have to hold it and store it always vertical, but you should not store it with a pipette tip on it. But in general, it's often mentioned, but you can lay down your pipette. This is not a problem. In general, as I mentioned, without any tip or liquid. But I would recommend to have sorted out more on the table, to have it in a vertical option. And Adam, can you repeat the second part, to have it on the on the nominal volume position? Was it right?
That's correct. Yeah. On the biggest volume.
To be honest, I never heard about that before. Ulrike, do you have more knowledge on that topic?
No, but there are a lot of myths out there. So you can, if you put it in the pipette into the pipetting stand, you can just leave it. You don't have to set it to 1,000 microliter when it is, for example, 1,000 microliter pipette. We call it the nominal volume, by the way. So the volume you can, the maximum volume you can of the volume range printed on the pipette is called the nominal volume, but there is no need really to store it at the nominal volume.
For me, it was always new. I never had that question, but it's funny. You can work for years with a topic, and you have always new questions. Thanks for that. So interesting question.
Thank you, Barbara. Ulrike, the next one's for you, and this is from John, who asks, in calibration of pipettes, is this standard all over the world since many companies are involved in production?
Okay, the calibration, I don't get I have problem to bring together the production and the calibration. So when you are thinking about the calibration in calibration service labs, so there are, of course, different quality standards, let's put it this way. And if you have or if you have the need or you wish to choose the highest quality standard, then you should choose an accredited calibration lab. Regarding the production, so our pipettes, I can only speak for Eppendorf. Our pipettes are manufactured in Hamburg in Germany, so they are not different manufacturing sites. And of course, the production or in production calibration and checking and the quality control is also done in Hamburg. Does it somehow answer your question?
Okay, well, I hope so. Thanks, Ulrike. Actually, the next question is also for you. This is from Khalid, who asks, what is the lifetime of a mechanical pipette?
Yeah, okay. Yeah, the lifetime is as long as you keep it maintained. So when we speak about a mechanical pipette, Eppendorf gives 3 years warranty. But to my knowledge, and I get feedback from from a lot of customers, also through these trainings, who say, oh, I opened a drawer and there was an old Eppendorf pipette that was more than 20 years old and it's still working. Yeah, this is completely true. So, I mean, it's mechanics inside, and these mechanics, it's like a, like a watch. Yeah, it's working forever, so to say. The only thing you should take care of is that you maintain your pipettes, especially when you're working with, for example, contaminating solutions. You have to make sure that nothing, sticks in the cone or, disturbs the functionality of the piston, for example. So clean them, maintain them, send them to calibration, or do the calibration yourself if you can. And then you will have, a very long lifetime of your pipette. So there's no end date.
Thanks, Ulrike. This next question I think is very interesting, and this, Ulrike, is also for you, I think. There are instances, this one's from Silo Marquez, who asks, there are instances where labs reuse pipettes for various reasons. What are your thoughts on this? And how is reusing the tips, how does that affect low retention function of the tips?
Yeah, to reuse pipettes is completely okay. As said, just make sure when you take them over that they are send them to a calibration lab or make the maintenance yourself and the calibration, just to make sure that the everything's okay with the device. Reusing of the tips is a different question. So the pipette tip is a single-use item, and that does not mean that you are only allowed to make only one pipetting with it. So we all know that, for example, if we do a dispensing of a plate, we attach the pipette tips to a multi-channel pipette and use it for the full plate. So that's obviously more than one pipetting step. And this is fully okay. What you should not do is, wash the pipette tips and reuse them again, because there is a contamination risk, of course, how to get that clean, really. And the second point is that you have there are molecules of the water going along the pipette wall, the tips wall. And after, I don't know, I have no real number in my head now, but after a high number of movements of these molecules, the surface of the tip may be affected, and the liquid may tend to retent a little bit more, but this is nothing that you should make be really concerned about. As long as you're completely safe, as long as you are attaching your tips, filling your plate, and that's it, and then you throw it away.
Okay, thanks, Ulrika. Barbara, this question's for you from Laura, who asks, when you use the same pipette tip multiple times, the pipette to pipette the same volume, what will be the influence on this, on the pipetting error, and when do you need to change tips?
Hey, Laura, and thanks for your question. A good question. We had that topic shortly before, but not in the presentation itself. Is a pre-wetting. So there is always an influence, and you find also diagrams on that on our landing page in the handling solutions. That when you pre-wet your pipette tip 3, 4, 5 times, you come closer to the correct volume. And when you pipette then, I don't know, 10 times with the same pipette tip, you stay on the same volume. But this is maybe for aqueous solutions or more unproblematic solutions. As I mentioned before, when you use foaming liquids, you should very often change your pipette tip, because the problem with the foaming increases always when you pipette again and again and again with the same pipette tip. And so it, again, as we always have to point that out, it depends totally on the liquid you're using and on your approach or application. So I would say with unproblematic liquids, you can use it. I can tell you a number, but you can use it more often the same tip. With problematic liquids, with ethanol, for example, there is a pre-wetting very important. So there is better you do it more than one time to pipette, pre-wet first, and then you can do it different times. Then the problem decreases. With foaming, it increases when you use a pipette tip lots of times. So yeah, it's really the question of the liquid. And if you want to know more, please give us a hint directly, and then we can talk about that. Thank you.
Thanks, Barbara. Actually, staying with you there, this question's from John, who asks, what ways are there to test the performance of a pipette in the lab?
Good question. Thanks so much. And it's really recommended to do some tests in the lab. A very easy thing is that you make a leak test or leakage test with your pipette, and everybody can do it on their own to fit the tip to the pipette, and use water and hold the pipette really vertically and wait 1 minute. And if you see not only drops like in the video of the ethanol, but also if you see only a very, very small building up of a bubble, then maybe your pipette is not in a good shape, or the system is not good. So pipette or the pipette tip fits not well to the pipette. And this is the first test you can do, and maybe it depends again how accurate your applications need to be. You can do it every day, every week, every month. This is very easy. And with higher volumes, if you have what is the wording, a balance, maybe with 1,000 or 100 microliter pipette, you should sometimes try to pipette that on your balance and check out if the results are the same as they should be. But this is not possible in the most cases for small volumes, and so we would recommend, I saw another question from another person, the periods of calibration. The ISO norm, this is so to say our Bible, recommends 1 time a year a calibration, and then there will be checked everything really properly, also the things you are not able to do in your lab. But it depends on your standard operation procedure in the lab, if you have to do it much more often, maybe every 6 months or every 3 months. But the leakage test, and maybe to check with a balance with bigger volumes, you can do on your own in your lab. I hope that answers your question, John.
Yes, thank you, Barbara. I think you also answered someone else's question there at the same time, so that's very helpful. Thank you. Ulrika, this question's for you, and this is from Eleftheria, who asks, when reverse pipetting, is it correct to do serial pipetting, or do we have to use a different pipette every time?
Yeah, that's a good question. So reverse pipetting means that you have that you leave a certain amount of liquid in your tip, which is to be discarded then. So the advantage is that most, for example, when doing or pipetting viscous liquids, that the error will be in that volume that you discard afterwards. So from that side, that speaks nothing against doing a serial dispensing with the reverse pipetting, to my eyes.
Okay, thanks. And the same person actually also asked, can we pipette phenol with plastic tips?
Yeah, okay. I just, in parallel, I just checked out our chemical compatibility chart. And so I do not recommend in this case, to go for the positive displacement principle, surprisingly. So phenol is an organic solvent. So from that side, the multipette or the positive displacement principle would be the right choice. But we have a inconsistency, or let's say we have a in advantage with the chemical compatibility with phenol. So when you use it very, very short, it might be okay, but you should not have it in longer contact. So the other option, the air cushion pipette, would be okay, but also there's a but. So the polypropylene is resistant to phenol, but the seals in the pipette are not. So when you wish to pipette phenol with an air cushion pipette, then you should take care to have a very short interaction time, and or keep in mind that you have a higher maintenance frequency, because this piston seal will, wear out faster. This is what I meant with aggressive liquids during the webinar. So yeah, phenol actually really is one of the liquids that are a little bit problematic. Yeah, that's true. So go for positive displacement only if you have smaller volumes, and if you have very short contact times. Don't leave it for longer in the tip. And if you go for the air cushion, then make sure that you have a smaller maintenance cycle.
Okay, thanks, Ulrika. Staying with you, actually, a question from Norania, who asks, is the positive displacement pipette available in the Philippines?
That's a very good question. Yeah. So our positive displacement instruments are called multipette M4 and multipette E3 or E3X, which is the electronic version. And they are part of the catalog. So they will be available also in the Philippines, as they are part of the catalog.
Okay, thank you, Ulrika. Barbara, this one is from Alicia, who asks, what type of tips should be prepared, filtered or non-filtered?
Oh, a good question. In general, for aqueous solutions, it's absolutely fine to work with normal tips without a filter. But when you have aggressive or not problematic, I guess the best word is aggressive liquids, we recommend absolutely the filter tips. To avoid the aerosol building inside the air cushion. We at Eppendorf, we have dual filter tips, so it sort out not only small liquid drops, but also really the aerosols, and so you save your pipette with that, so that you avoid in general the aerosols. You have to take care maybe that you have to work a bit slower. You should always work very slow, but to work a bit slower when you use filter tips, because the liquid needs a bit more time to aspirate or to rinse into the pipette tip. So it really depends. Again, this question is not easy to answer in general on the liquid, on your application, and what do you need.
That's great. That's great. Thank you. Actually, staying with you there, another question from Vinay, who asks, what should one do when some viscous liquid like enzymes stick to the outside of the pipette tip while aspiration?
Okay. Thanks for that question. I would say in the first line we didn't point that out more in detail in the webinar, but you will find that later on in the ebook about the correct pipetting. You can avoid that mostly because of the immersion depths. So a lot of people are not taking care on that, and deep dive with a pipette tip, too deep into the liquid, and then you have liquid outside of the pipette tip. So the best thing is to really take care on the depths, to go with the tip inside the liquid. And so how do you say that? Oh, I don't know. Sorry, I'm not a native speaker. I miss a word. But so use a very little immersion depths. This avoids that, and I don't know if I would recommend it. You can very carefully when you, but it's a bit dangerous to go with a wipe outside the pipette tip, but then you can cause a problem that you suck liquid out of the tip. So it's a bit dangerous. If you are really a professional in pipetting, you can do it maybe like that. But the best choice is really to take care of the immersion depths and work really on the surface.
Okay. Thanks, Barbara. Just a few more questions, staying with you again here from Etefe, who says, thanks for a very informative webinar. And I think you've covered calibration, but this is an interesting question. How often should we calibrate our pipettes? And is there a way you could check this in the lab? Since I heard about weighing some drops, weighing the drops and comparing them with the volume.
Okay. So as I mentioned before shortly, the recommendation, not from us, but from the ISO norm 86552 is that you should calibrate your pipette in a calibration lab at least one time a year. But this is only a recommendation, and it totally depends on on so many things. How many people uses a pipette? Is it only you or are different users working with a pipette? What are the type of liquids? Are they aggressive? Then you have to calibrate it more, maybe more than one time a year. What recommends you SOP if you have one in your lab? In lots of labs, you have defined SOPs who define that that period of calibration. What else? Ulrike, do you have more points to what could be influence the aggressive liquids, the users? So I would say these are the most important topics. So we cannot give you an answer. You have to do it one time a year or every 6 months. So it really depends again on the circumstances in your lab.
Yeah, Barbara, this is completely correct. Just a side note to that, the ISO 8655, as said, this is so I call it the Bible of liquid handling. So that's a standard, an international standard, and that recommends a calibration at least once a year. And as Barbara said, it belongs very much on the use. So it's also the frequency of use. How heavy is the pipette becoming used? How aggressive are the liquids? How many users are there? Because everybody uses the pipette a little bit different. So there is a bunch of different factors that come into play. But there's one thing which is really important. And this is, please focus on your analysis. So if you have a very sensitive analysis, it may be a good idea to calibrate the pipette more often than when you are, doing just pipetting 10 milliliters from A to B. And there's no requirement in terms of the accuracy. So focus on your analysis. What does your analysis really need? And from that side, you can answer this question, how often a pipette should be calibrated, taking into account how aggressive is your liquid, how many or how heavily is the pipette used.
Okay.
Thanks.
All right. Well, thank you both. We have so many questions, and to the audience, please be assured that that we will endeavor to answer these questions offline. The questions will be sent to the speakers. So that brings us to the end of today's webinar. Thanks again, Barbara and Ulrike, for a very illuminating presentation and a great discussion, I think. And thanks also to our sponsor, Eppendorf. And finally, thanks to you, the audience, for taking the time to attend and listen. So until next time, good luck in your research and goodbye from all of us at Eppendorf and Bite Size Bio. Thank you.